Limit is y goes to negative 2 of the square root of y squared minus 12 divided by y minus 2 all over y squared plus 3y plus 2. The first thing we're going to do is try plugging a negative 2 in for the y's. That will give us the square root of negative 2 squared minus 12 divided by negative 2 minus 2 all over negative 2 squared plus 3 times a negative 2 plus a 2. So in the numerator we have the square root of negative 2 squared is 4 minus 12 divided by negative 2 minus 2 over negative 2 squared is 4 plus 3 times negative 2 is a negative 6 plus a 2 in the denominator. In the numerator, square root of 4 minus 12, negative 8, divided by negative 2, minus 2. In the denominator, 4 minus 6 is a negative 2 plus 2. The numerator, square root of negative 8 divided by negative 2 is the square root of 4, minus 2, over negative 2 plus 2. The square root of 4 is a 2, minus a 2, over a negative 2, plus a 2. And we're ending up with the 0 over 0 indeterminate form. We will need to rework this. Since we have a root combination, a root involving the variable y in some way, added or subtracted together with at least one other term that's happening in the numerator, we can try the root conjugate method. So I'm going to rewrite the limit exactly as we see it so that we can multiply it by the root conjugate. Now, the root conjugate is going to be the same expression involving the root combination except opposite sign between the terms. So it will be a plus 2. I'm going to put it over itself so that we have a form of 1 because we're about to multiply these, and multiplying by 1 won't change the value. It's just going to change the look. We'll have limit as y goes to negative 2. In the numerator, we have root conjugates. We will FOIL that out first. Root of y squared minus 12 over y times the root of y squared minus 12 over y will give us y squared minus 12 over y. Outside, root of y squared minus 12 over y times a positive 2. Inside, negative 2 times the root of y squared minus 12 over y. And then last, at negative 2 times a positive 2 is a negative 4. After FOILing out the root conjugate, the outside and inside terms should be equal value opposite signs, so they will be able to cancel out. In the denominator, we do not have root conjugates, so I will not FOIL the denominator out. They are multiplying each other, but I'm going to keep them multiplying in a factored form. So we have the limit as y goes to negative 2 of y squared minus 12 over y minus 4 divided by the entire denominator of y squared plus 3y plus 2 times the square root of y squared minus 12 over y plus 2. We still have 0 over 0. That hasn't changed yet. Multiplying by a root conjugate doesn't change it. It just changes the form. And the form is now we have a fraction involving y in some way. And we can therefore try the common denominator method to combine with that 4. The common denominator is going to be a y, so I'm going to multiply that 4 by a y over y. That gives us limit as y goes to negative 2 of y squared minus 12 over y minus 4y over y, and then all of this over that same denominator. So I will just rewrite that exactly as we see it. And now we can combine together those two fractions that have the common denominator. That will give us a y squared, I'll write the minus 4y next, and then minus 12. Just put it in descending order. All of that is over a y. And then the entire thing over that overall denominator. The next step in a common denominator fraction method is to take the denominator, reciprocate it, and multiply it times the numerator fraction. So we have limit as y goes to negative 2 of y squared minus 4y minus 12 over y, multiplying by the reciprocal of the denominator. And the denominator doesn't really have itself its own denominator, but you can put it over a 1 and reciprocate it, and it'll be 1 divided by all of that. Y squared plus 3y plus 2, and then square root of y squared minus 12 over y plus 2. And we can now multiply the numerator and denominators with each other. So that will be limit as y goes to negative 2 of, in the numerator, 1 times will give us just y squared minus 4y minus 12. And in the denominator, we will have y times y squared plus 3y plus 2 times the square root of y squared minus 12 over y plus 2. The common denominator method also does not change the 0 over 0 result. We still have it, and it will continue to be there until we can cancel out factors of some sort. Now, since y is going to negative 2, I would expect a y plus 2 factor in both the numerator and denominator. Now, that is going to be happening somewhere here in the numerator and somewhere here in the denominator. Those are going to need to be factored. And that's going to be our next step, is to trinomial factor those. So limit as y goes to negative 2 of, in the numerator, I need two numbers that multiply to be a negative 12 and add to be a negative 4. It sounds like a negative 6 and a positive 2 will take care of that. In the denominator, I have a y. Then I have the trinomial factoring, which I need two numbers that multiply to be a positive 2 and add to be a positive 3. So it sounds like a positive 1 and a positive 2 will take care of that for us. And then we also have the other expression, still multiplying this. So I'll write that in there. There's the y plus 2's as expected. We can now cancel those. We've removed the 0 over 0 finally. Leaving a numerator of y minus 6 and a denominator of y times y plus 1 times the square root of y squared minus 12 over y plus a 2. Since we no longer have 0 over 0, we can now plug a negative 2 in for each of the y's. That will give us a negative 2 minus a 6 all over a negative 2 times a negative 2 plus 1 times the square root of negative 2 squared minus 12 divided by negative 2 and then plus 2. In the numerator, negative 2 minus 6 is a negative 8. In the denominator, we have a negative 2 times a negative 2 plus 1, which is a negative 1, times the square root of negative 2 squared, which is 4, minus 12, over negative 2, plus 2. So we'll have a negative 2 divided by negative 2 times negative 1 is a positive 2. And we will have the square root of 4 minus 12, which is negative 8 divided by negative 2, and then plus 2. Now the negative 8 and the 2 can cancel partially by a factor of 2, leaving a 4 in the numerator with the negative still. So negative 4 divided by, and the square root of negative 8 over negative 2 is the square root of 4 plus 2. So we have negative 4 over the square root of 4, which is 2, plus 2. We have negative 4 divided by 4. The 4's can cancel, leaving us with a negative 1.